Welcome to SingularityNET. Today we're going to talk about how to connect AI into the SingularityNET system. For our example, we'll be integrating a Tensorflow MNIST AI agent. To get started, the first thing we'll need to do is launch the SingularityNET agent. This is very difficult, as you're about to see. We have to type a few letters, tools.sh Alice, which is the name of our first agent. Hit return, and that will launch Docker containers setting up SingularityNET, and it will open a JSON RPC socket at 9050 as well as an HTTP socket at 9050. And as soon as this goes up, we can go over to Chrome and refresh, and then we'll be able to see that there's a WebSocket here. And if we press, in our example, we've got the ability to execute a couple agents. The first agent is a simple one. We'll look at that first. As you can see, there's a JSON RPC command to call perform on a service node ID, which this particular GUID, and it passes a set of parameters. The parameters are what get passed into the agent. In this case, it's basically saying our input type is a file, and it's located at this URL, and output type is going to be another URL, and it's going to be a particular name. For the case of the MNIST classifier, what we're going to be doing instead is we're going to be passing in something a little bit more complicated. Let's try that and we'll see what happens. As you can see, we have a couple more results that came back. The perform itself, we're passing in input data, which is images, and this is a 784 28 by 28 essentially vector of image pixels, and we're going to see that what came back was that it was predicted to be a 7 with a confidence of 1, so it was completely confident that it received a 7, which is in fact our test case. There are three fairly common methods on the service adapter abstract base class: the init, where you might want to initialize member variables to a known state, and the post load initialize, where all of the service adapters have already been loaded, so you can connect up with other service adapters if you need to, or it's a good place for connecting and loading training data or model data for doing classification. The classification work is done in the perform method. This is the method called by JSON RPC from JavaScript in our example. In the TensorFlow MNIST service adapter, we're not going to be doing anything in init, and we're going to be loading and training the neural network in post-load initialize, but we're going to cache it so that if we have cache files, we do not need to do the training, and that way our agent can come up quickly. And perform will do the actual classification. So now let's look at the JavaScript file for our input data, in this case the send perform MNIST. The input data is just an array of images. In our case we only have one, so the array is of length 1. Here is the floats we sent in, and then the output type again is attached. So the result, as we saw before, the classification itself gets passed back to the same application. Now let's take a look at the service adapter base class. Again, init initializes some service adapter member variables. In this particular case, the important one to remember here is required services. So if this particular service relies on other SingularityNET services, they might be listed here. Requirements met, when that gets set to be true, an available, which is a flag which defines whether or not the particular service is currently up or not. that's used by the rest of the system to manage a few things automatically. We don't need to do anything in the MNIST example. These defaults work perfectly fine for us. And then there's post-load initialize, and again, that recursively calls all of the required service post-load initialize. So if you have a service that relies on 3 or 4 other services, they'll all get loaded together and initialized together. There's start and stop, where you can take a service online and offline. Can perform, which is a function that's used to save cost on the network, because you can directly ask the agent if it can perform something before you send a request that is going to involve a blockchain contract and potentially some gas costs or something. And then the perform method is where the bulk of the work gets done. And let's go take a look at the specific example of the MNIST classifier. So the MNIST service adapter doesn't really do anything except for check the classifier ID in the init, but in post-load initialize, we do the bulk of the training and loading of the model for the classifier. So if you're familiar with the MNIST example, I'm not going to spend a lot of time here. It's essentially the same kind of code. The only difference is that we have put some of the variables, changed some of the names, and made them member variables. So put a self in front of them, because we're going to need the references when we do the actual classification. So input images and the classifier graph itself and a couple other things like the path to the model are saved, so that later on you can see in this particular case down here, we're checking to see if the path exists, and then we're loading the model and optionally checking for accuracy. If you want to check the reliability or the accuracy of your classifier, you can set that flag to be true. The bulk of the work is being done in perform, however. And again, what we do is start a session, we restore the model, and then we go one by one through each of the job items in the job. We take the inputs and pull them out of the data that was supplied with the JSON RPC request. So we take do some sanity checking on the types, and then we run the actual classifier. And then by setting up a couple extra things that aren't in the standard MNIST example tutorial, we're able to pull the confidence out and get the prediction. So the prediction confidence and the prediction are both stored and sent out in the results. And this is basically pulled together for every job so that there's an array of results that goes back. So if you passed 4 jobs in, each of which had 3 images, then you would get 12 total classifications, but chunked up by job item. So now that we've got this classifier, how did we get it to load? In the case of Alice, the simplest way is to build just add a line in the configuration YAML file. You can see down here we added a line saying that we have a service. Here's the service ID, which is a GUID identifying uniquely this particular service. And the module that we want to load is demo.tensorflow MNIST. Tensorflow MNIST is a class, and that's all you need to do, and it will load it up. Thank you for listening, and if you have any more questions, please look at additional resources or the SingularityNET GitHub site. That's github.com/singnet. Thank you.